Okie dokie. So we need to we basically need to program these now. Cube connected XYZ. This one here is not so simple. We need to check some stuff here. If alignment is like that. So here we need 6 checks. Zero, 2, 0, 2, and 0, 2. All of these are false. Then configuration matrix equals 1. But here we only need to check 2. If both of these have an alignment matrix there, this is called configuration. Like so. Like that, and this is supposed to be this cube connected X. Here it's the y. And here it is z. Yeah. And then this, what was this supposed to be? These are all positive. Right, forward, and back. This is when you're aligned it down. So if this is surface, isn't it? This is surface. Surface up. And these... I'm not so sure about. I mean... No, this is surface up. Meaning this one. That's surface up. And then this here. This is supposed to be a concave, I think. So we've already checked here all of the surrounding are true. And here we're checking that one isn't rotated, or one isn't, only one is empty. And this should be concave. Down. I guess we kind of just have to decide which is which, but I think this has to be a little bit different. Because these are connected to multiple, right? So it's not as simple as this. Down L. This has to be like down front left, left back, back right, right front. And this has to be the same. Like, it has to be the same here too. And the convex is the same too here. And here it's connected to front. It's gonna go around in a circle. Where does it start? Down? Front, down left. Left top. Top right. Right down. Back plus down plus left. I just want to make sure. That I have some logic written down here. And the slopes are all good. Right, so here, this would be down. And if this is right towards, this is the bottom right, then the top left corner, that would be back and left. So this would be concave, down, left and back. And then here, this is then the same, except here it's 2, 1, 2. So that's top, back right. That's empty. And this then means left and front. Front and left. Is that a thing? Yeah, right? And this one here, this is 012. That's left away. That's there. So we are at front right. So that's RF. And then there's only one left. Right front, front left, left back, back right. Now what do we have here? This is the one that I'm not sure about. This is the so I think we're gonna leave this until last. So that's what that's gonna do. And now we have to go here. Why did I do this? I feel like that was stupid. Let's go up again. No, never mind, it's a float 3. Right, it makes sense. Yeah, this is one of those things that it's just gonna suck. There's no good way to do this. And now I want to make the connected cubes. So that's going to be index equals 28. And this is connected in the X. So that means we delete these two. And we then rather we do that. And then we can just replace this, right? Like this is the same as here. No. Then we delete these. Whoops. And then 29, it's not going to have front and back. So then it's going to be I kind of wish it was like this. Instead. What are you doing, man? There. And the reason for that is so that it makes it easier to select all there. But so here then, this is connected in the Y. So this is no longer bottom, this is left. This is right. And right is 3, 7, 2, 7, 6, 2. This is back. Back is 7, 4, 6, 4, 5, 6. This is cube connected Z. Bottom. Left, right, back. It was almost immediately. No, this is top. Here, 1, 2, 3, 4, 5, 6, 7. Now, what about... Well, whatever. I wonder if this just runs already. It's a bit odd. But it is the correct one that is being rendered there. And it is... It is actually rendering correctly, I think. It's just that its neighbors are not connecting. Or its neighbors aren't there. And it doesn't have sides. So because it doesn't have sides, we're just passing right through it. So it's actually correct. But now the question is, that's a cube. But should that be a cube? Because I feel like the cubes are special. I feel like the cubes are... They're like, a rigid object. Because I think I should have a distinction between the two already here. Like a cube that should be a rigid object. And then we should have like... I don't know what to call it. Is there... Basically, it's gonna say if... I don't know. I feel like I maybe need something here, and this is supposed to be called like... smooth. Or something like that. And then anything that's 85 to 114, or like anything that's greater than cube connected, it should be smoothed. But anything down here should not be smoothed at all. No smooth logic here. And in that scenario, I feel like here, It depends on the index, the color index. But I don't have a lookup table right now. So I feel like this should be smooth connected. We can do cube aligned, because if it looks like that, then I don't have any real options. It's like either I render it as a sphere or I render it this way. Dude, is there... Can you have like a header file in HLSL? Or like something where I can have... I don't know how headers work. This is gonna be like infinity lines long. This is gonna take for eternity. Hey, Albine, how's it going? Let's fix these as well. If we do this, it'll fix itself. That. It's going terribly. It's going horrible. If you imagine every single configuration that a cube can be in, if you allow it to like slope and like connect with nearby cubes, every single rotation and every single shape that they can form is what I am writing here manually. Once I get past a certain point, I think there's going to be a lot of copy pasting. That's at least my hope. How's the drawing going? How's the drawing? And then this is now a different value. This is smooth connected. So this is 112. 113. 114. Yeah, well, doing some exercising is still good. It's good to keep some fear, maybe. But like, if we look at it like this, like here, right now this is what I'm setting up. So here, this is just a surface. This is the connected surface. It connects to these two. But this here, this is then smooth connected to the left, and this is smooth connected to the right. But what if I added the stuff here? Like, what if we have this? What is this then? This is just... Now this is just connected here. That's all it is. It's just connected here and here. Or, no, this would be a slope, wouldn't it? Like, this is a slope. That's what this is. I feel like this is not good. This should all be... separated out like this. That was down. And we have up. And this should be left. And right. And this is front and back. You know what? I've changed my mind. What I'm doing is stupid. Not this whole thing, but this. This is stupid. More or less. It's not that simple, actually. Well, because the issue is, right, I'm trying to connect them all together. So right now what I'm doing here is, this is something called marching cubes, but I'm doing my own implementation, which is really stupid, but that's what I'm doing. So basically, after I've placed all the voxels, each voxel has its own internal volume. And then I go through all the voxels after they've been placed, and I check its neighbors. And based on what its neighbors are, I then try to connect the corners and the edges to its neighbors to create like smooth slopes and stuff. So I have a couple of shapes. I have this kind of cone. This is an outer corner. We have an inner corner here. I've got a slope. We've got a cube. And we also got this, maybe, I'm not sure. So those are basically the shapes I have. So this here is if you have another voxel on this side, on that side, and on that side. But down here in this corner, there's nothing. But on all the other corners, there's a voxel. That means that this here is an inner corner. So then I want to set this shape. But it's really hard to just say this is the shape that it's gonna be and just send that to the GPU, because it needs a lot of information to say that. Because this is just like one rotation of this. There also needs to be a version that's from this side and to this side and to that side. So then you also need to have like a way of storing rotations. And rotations are actually quite complicated because you need to be able to like rotate around your own axis as well. So each combination of rotations is actually quite a lot of data. So what you can do is you can try to send like rotational information and then try to use that on the GPU to then figure out how to draw this thing. But what I'm doing now and what marching cubes means is that you already reallocate the configuration of all of the vertices of a cube, and then you just apply an index to the voxel itself based on its configuration, and you're like, okay, it's a slope that's pointing to the right and down, that's index 54. And then when I read the voxel on the GPU, I just get the index, and then I go here and I fetch the index, which is 54. Then that returns all of the vertices that a slope in that direction would use, and all of the triangles it would use. So that's what I'm trying to do. I was doing it dynamically before, and it worked, except there's like a few edge cases where it kind of breaks. I could have maybe made it work with some more tricks, but it was really, really, really tricky. Because the tricky part is that if this is what a cube looks like, these are your vertices, and they have a rendering order, right? And in order for me to draw a triangle, I have to draw it in a certain order. So here it would be 0 to 3, then 3 to 1, then 1 to 0. Here 3 to 2, 2 to 1, 1 to 3. Those are the two triangles for this side. But you see that it creates a seam here in the middle, and that's the problem. Because this seam here determines how this square can be transformed. So if I take this corner here and I pull it like down here, then you can get a shape like this. But if I take this corner and pull it down here, then you can see that it's just going to pass by the line. And then we get an inverted triangle. So it breaks the shape. And in order to get around that, you then have to flip it. You have to flip this like that. Yeah, it does come from trying to connect them, but also mainly if I was just trying to connect them only, then it would be not that bad, because algorithms like marching cubes are already well developed and freely available online, so you can just go and grab it and then just like implement it and it works. More or less. But I also want the cubes to have volume, meaning that even after because what I'm doing now, right, is if we have a shape like this, then I'm loading the triangles needed to render this just via an index. So I'm just setting like my first vertex to be this, and second to be this, and third to be that, and fourth to be that, and then I just draw two triangles here, and then I'm just drawing this properly, right? But since I want volume, that means I have to do additional calculations on like these here to make sure that this actually like aligns with its neighbor. And that's the real tricky part. Because otherwise you're just gonna get, like, you might have more than cubes, you might have slopes, but you're just gonna end up with like terrain that looks like this. It's not gonna be like super smooth. It's still gonna have pretty sharp corners everywhere. And well, for me, I want this to be like this. You know, like this one is like, has this amount of volume in it, and this one has another amount of volume. Like this is basically this unit's volume, and here's this volume, and this is this volume. And this one has a max volume. Here the volume is max, and then I want to connect it together like that. Well, this is how you fix the issue. Create an enormous list of enums, and then you manually assign everything. But yeah, I think I don't want to do this anymore. Because I was thinking that instead of it being like that, what I should do is I should have one bit that just determines whether it's smooth or solid. But for now, I just want to do smooth. Smooth. And that should not be based on this configuration. That should be based on the color index. The color index should be changed to another value or another name later, because this is actually the block index. This is just gonna refer to if it's a grass block or a dirt block or whatever. The most difficult part later is gonna be figuring out how I want like buildings and stuff to work. That's something I haven't really decided on. I was planning on doing the same kind of approach that they do in Teardown, but it's really, really, really difficult, I think. In Teardown, they basically, if you have an object, you then ray trace into that object's like boundaries, and then you see if you intersect with anything in there. It's kind of like ray tracing from one world into another world, and then you see if you. But the issue with stuff like that is like, because I wanted to be able to build and place things in like a non-cube aligned fashion. But I don't know if I want to do that. I kind of do, but I don't know if it's feasible. So, like if you have a CubeNet, and you then want a house that's like this or something. Then you'd need to create like an area here where you like ray trace into this area to be able to collide with this. But the problem is, if I do this, this doesn't really solve the problem, because this is now a grid in here. So it's still like actually locked to a grid. It's just that the grid is like slightly rotated. And then this creates further issues with like now you're in this area, you're like completely locked and you can't place things in another manner. And it's weird. I don't know. We'll work on that when I get there. Worst case scenario, I just place blocks. But I would like it to not be that way. I would like, if possible, I would like houses to be a little bit more free. It is possible to combine the Raymarching technique, I think, and just standard rasterization technique as well. But I think that would be difficult. But with that, I could just have objects that are just meshed, and then it could just be built like it's Valheim or something, using some kind of points or whatever. I don't know. We'll deal with that when we get there. So here now, this here is if we are connected everywhere. There is a possibility of using the alignment to clean up some of this. Because if I just have a cube here, then I can just load a different configuration based on its alignment. Like if I just say that this is a cube, like so. Then the alignment would determine the rest. And the same thing is true with some of these. A concave can't have this solution, but a convex can. Because a convex corner always has realignments. But it's not necessarily simple either, I think. There's this one, for example, right? This one is aligned down, left, and back. But it could be flipped. I think. Couldn't it? No, it's the same shape. Wait, am I stupid? Voxels are genuinely super easy. It's like, it doesn't get easier than voxels. To be perfectly honest. I think out of all game concepts, voxels are probably the easiest thing. Yeah, it's like, do you understand how tiles work? Like, if you want to make a game and you want to just use a tile set to create the world, you just say that you have like, oh, I have a grass block, I have a dirt block, I have a water block, and then you number them. So you have 0 is like an air block, 1 is grass, 2 is dirt, 3 is water. And then in order to create the world, you just give you just create let's say this is 2D, so this is tiles, right? You just create a 2-dimensional array. And then in that array, in order to place dirt blocks, you just paint like 2, 2, 2, 2, 2. And then this becomes dirt blocks because it's just referring to this, right? And then you can place like 1s up here. This is 1, 1, 1, 1, 1. This is a tile system. And then if you just have a character here, if you're just standing like here, and then all you do is you just mouse over this tile here, then you just make a little check versus your character, see if it's within range, and then if you click this, bam, it's destroyed. Or it has like, you store like a ramping value that's just like, when this value reaches 1, this is destroyed. And voxels are just this, but in 3D. There's no difference. A voxel is literally a 3D pixel. Am I stupid? I'm trying to think here. Like, what would this look like? This would be like... Oh, it's not possible. But I could do like... like this? right? But I think this is a shape that wouldn't exist. Because this, I feel like this is really just about having because this shape is the same as this shape, right? This is aligned down, left, and back. Just like this shape here. But it's a little different because it's like, this is like a major alignment, right? And here it's based on this vertex. But I wonder if this is another one of those scenarios where it's more about determining what is your primary, or what is your dominant axis. Because in that scenario, this shape would never exist, I think. Like, kind of not really. Because if we had a scenario maybe it would. No. Would it? No. No, I don't think this shape would ever exist. It would have to be manually set to be this specific rotation. Otherwise, in every other automated scenario, this should just end up as this. But in terms of like construction, this could be useful to have. Like maybe if you place this block by targeting this side here, that sets its dominant axis. Like if you place it down here, then down is the dominant. If you place it here, then that's the dominant. If you place it here, that's the dominant. Because there is a third shape, right? There's this. That's the third variant. Hmm. But I do think that this one is pretty solid. There really is not a lot of ways to draw this. And the slope as well is a little... I drew a scenario yesterday, right? Whereas here, if we have this here, then this is something, right? But I think this should just be a connected cube. with an alignment. I think that's what this is. And if we add something here, then this becomes a slope, right? And this has an alignment of down and back now. So something that has two alignments, I think, is always a slope. Because if it's a concave corner, then it has a no alignment. And if it's a convex corner, then it has 3 alignments. So 2 alignments is always a slope. And I think the way I'm gonna do it is no, let's say that it's a slope. Because there are see the tricky part here is that if I want to combine solid and malleable tiles or voxels, then if I have like let's say a slope, then the slope is going to render, or it's going to load its triangles in one way if it's malleable. Because if it's malleable, that means it doesn't need to have like its backsides, because those are just going to be connected to another tile. Actually, But yeah, but if it's a solid, then it could just be like a slope, and the slope is just standing on its own, and there's nothing else around it, right? And that's gonna need something here, like it's just gonna have a voxel config assigned to it from the get-go instead of generating one. But the thing about it is that it means that I have to have like a boolean in here when I'm gonna unload it that says like, okay, this is a slope, so we're only gonna load 2 triangles, but if it's a solid, it needs to also load all the other triangles, every single other triangle. Right. Even if it's aligned, it needs to have all of them. But the trade-off between the two is that if it's a malleable one, then we load less tries, but we have to do math on them. But if it's a solid, then we load more tries, but we don't do any math on them at all. And so here, this is a surface, right? I think a surface should also just be surface. And slopes. Slopes should just be slope. And in that case, I'm gonna move slope, cube, slope, and surface all next to each other here. Unless I end up changing my mind again. And again, a convex, I'm not sure. Because I think a convex also can be like this. It's just... Because a convex always is assigned to 3 axes. That means that it's always attached to top or bottom. And I think maybe I have to do it the hard way. And in that case, it actually needs 8 more inputs here. Because I have down, up, front, back, but... if we also want right and left, which I think we do. Because the shapes are going to be needed for buildings eventually. But I kind of doubt that this is actually free. And that's something that worries me. Because I do feel like this needs to be stored as well. And if that's the case, you know, Yeah, just asking around because I'm worried about this. Just by the very nature of how it's done, won't work, right? And if that's the case, it will suck huge, gigantic balls to find that out after I've implemented like 100 of these. But here's the annoying part here. Even if I do this, even if we say cube equals 1, this is a cube. Even if I try to add an alignment here, like an alignment check, it's not so easy. Because I still basically have to repeat this whole thing for every alignment. And I think that's kind of just worse than just doing a triangle check. Isn't it? So I think we'll just do this. This is a cube, and see what I don't really like is that it's a -1 to 1. And I feel like that makes some of this just harder. It complicates the math most of the time. But even if it wasn't, if it was 0 to 1 only, it would still complicate the math, but in another area, right? Because now setting something to the center is easy, it's just 0. But otherwise it has to be 0.5, and yeah. Because it's still solvable though. But like, for example, if you have something that has an alignment of down, if the vertices are just set to 1 immediately, because they're aligned so that we're actually just rendering at the top, then in order to shift them down, you could just run multiplication on the vertex y and just subtract something from it just by multiplying it by a sub 1 value, right? If you wanted it to be at 80%, you just multiply it by 0.8 and you're done. But you can do the same thing now. It's just you have to you always have to add 1 to the value and then subtract 1 from the value, and it's just kind of shit. All right. But that's a cube, and it works here that we just sacrificed the fact that we have 2 extra triangles in order to not have to add a bunch of like giga shitloads of code here, because it would be this many cubes that we have to add, and that would suck ass. So let's not do that. But instead here we now need to have a slope, and this needs to be 101 down. No, this is a slope, so it's which slope should we start with? Like this. Down front. And see, the tricky part about a slope that I'm not really sure, I think we should render 2 extra triangles on every slope. Because the reason for that is here, for example, this is a slope. This is a slope that's pointing in that direction downwards. This is the top. This is the bottom. This one doesn't have any sides because it's covered by these 2 tiles. But this is still a slope. and this needs to have two sides. And it's another one of those, it's the same kind of scenario there, where is it really worth it to optimize this by having 3 indices for this, where one index is slope with no sides, one is slope with one side, and the next one is slope with the other side, and then you need another one that's slope with both sides. I don't think that's worth it. But this should be slope with front. In fact, it just looks like this. It's got a face and it's got sides. And so this slope is, what did I say? Down front. This is gonna be 7, 4, 2, and this one is 4, 1, 2. And then we need 2 sides. This is gonna be 3, 7, 2. And this is 4, 0, 1. And that means that we do have to take I think we'll take an int3 alignment. I don't like that it's a float. And then here we have to say if alignment equals this is another case where, like, what's better, using magic numbers or doing this? Especially when alignments have this many options, right? Because that would be an ass load of variables. But I think it's fine, because in this scenario, this is int zero, -1, -1. That's what this is. Because for each ray, or rather each thread, because a ray is a thread, we'll probably just do this once. You know, maybe 2 or 3 times. So it might not be that bad. But changing this to something else later, I think is fine. We can just test it. So what if we just do this? Go in a rotation, and then we do top. This doesn't work, by the way. I don't know if an all check is bad. It might be. And then this is down left. So now this is 3, 7, 2, 7, 6, 2. And the sides are 0, 3, 1. And 0, 3, 1, 7, 7, 4, 5. Down back looks like that. Down right looks like that. Down back, that's gonna be 7, 4, 2. Did I already set this one up? Seven, 4, 2, 4, 1, 2. And then the sides 3, 7, 2, 4, 0, 1. Gonna go back to drawing. All right, sounds good. Wait, I'm confused. Take care, dude. Down back is this one is correct. 372401. It's front that's wrong. No. No, I did this one wrong. This is 0, 3, 5. And 3, 6, 5. And then the sides are 3, 7, 6 and 4, 0, 5. Down right. And it's easier if I just draw it. So this is 4, 0, 6. Zero, 2, 6. And then the sides are 0, 3, 2. And 7, 4, 6. I think. Those are slopes. Half of them. Those are half of the slopes. This is going to be hard on the brain. So up front, that's going to look like that. Which fucking vertices am I supposed to use here? Because it needs to be counterclockwise, right? So I think this should be 3, 0, 6. And then this is 0, 5, 6. And then we have two sides. This is 0, 1, 5. And this is 3, 6, 2. Right. Up left. This is 0, 4, 2. Like this is a nightmare to set up. I'll be honest, but I have more or less, as long as I don't get fucked by this in the end. This is 462. As long as I don't get just mega fucked by this, then I feel like this is kind of when you're making art. At some point, you have to just do things. It's better to do things in like a bad way than it is to just infinitely try to do it faster. And this is one of those, more or less, where it feels very overwhelming, but as long as we just start, it'll get done. Four, 7, 1, 7, 2, 1. That's assuming that this actually works. If it doesn't, then I will cry. Like, legit, I don't know what I will do if this doesn't work. At some point, I'm gonna have to settle and just give up and do something that works. And then this is up and to the right. Seven, 3, 5. 3, 1, 5. 3, 2, 1. 7, 5, 6. And then this is slopes. However, we haven't set up slopes yet. These are all of those. Full cube and connected cubes. And then here, single alignment. Double alignment. Here's where things become a little more complicated. So let's do them in the same order. Down front, that's 100. But here's the thing, right? If this is down, and let's say we go around in a circle. And then the same ones, except this is 2. Unless I'm mistaken, all of these should be slope. Always. That's a lot of... That's a lot of guys knocked out, right? Yeah, I don't know if I should have this, right? Because it's one of those things. If I'm gonna use the alignment to do checks, like equals 0 and equals 1, then should they be ints? But then if I have to do mathematics with floats and ints, is that gonna suck ass? Right? We can say that it's a float. And then here, we need an alignment. Then we can say int3 voxel data 111 dot alignment. Does that make sense? It is actually returning an integer. So we could say that. And then there we do that. Let me tell you, this is eating up infinity registers, I think. This is a lot of shit. But I don't know. I really don't know. But yeah. Assigning lots of variables is not good. And then here we say current alignment instead. And now we run it and see what happens. Check the compile time. Still sub 10 seconds, that's good. I fucked up this one. I fucked this one up as well. There's some ghosting here. Look. What is that? See? Somehow there's a triangle there. What is that? The cube in the middle seems busted as well. Which is strange, because this one is not bugged. So that one should also not be bugged. But it's only rendering two sides there. But okay, this is the front. This is connected to top and back. Right? Four, 7, 1, 7, 2, 1, 6, 2, 1, 4, 5, 1. Yeah, this should be 4, 1, 5. Is there another one? Like, that one is busted. Up here. Down and left. We got the front fucked up. 3, 7. Yeah, this should be 3, 7, 1. 7, 5-1. Let's do this. That's a 0. If index equals 0, return. Try count equals 0. This is still really strange. I don't like it. Is that? What is this? Ghost shit. Ghost voxel. It's only in very specific points too. I'm not sure why it does that. Like sometimes it just glitches me in a direction and then the controls stop working. But it's unfortunate. It's like it's not actually running like well. That's one of the problems. Like 200 FPS here is... it's not actually good. But there might also still... there might be some things down here in just in the DDA algorithm that can be improved. Like just how I traverse could probably be improved. Because I don't really know what the best way would be. I almost think I am doing it the best way. Right? Because in order to quickly step through the voxel matrix with the DDA algorithm, we have to use acceleration structures, right? And the way I'm doing it is every 8 times 8 times 8 voxels is a brick. And if that brick is empty, then we skip. But the way it skips is that I have to switch resolution. And in order to switch resolution, we have to always keep track of the brick. Like, when I'm stepping through normally with just voxels, every time I enter a new brick, we have to iterate the brick. And if the brick is empty, then we step up to brick space. And the way we're doing that is that we actually have three rays that have different resolutions that we are iterating at the same time. And when you're at the lowest resolution, you're iterating all three rays at the same time, but you're only iterating the rays that are lower in resolution than you are. Or okay, when we are stepping through at a voxel resolution level, that's the highest resolution. And when we are doing that, we iterate the brick and I'm calling it a wall apparently here. So we we iterate the voxel, the brick, and the wall rays. But then if the brick is empty, we then only iterate the brick and the wall. If the wall is empty, we only iterate the wall. And when we are iterating only the wall, if we find a wall that isn't empty, we then have to recreate the ray for the brick on that position. And that means we have to recalculate everything, including its side dist, its delta, well, not its delta dist, but its side dist definitely has to be recalculated. And then I have to check for the voxel, and if the voxel, then we have to check the brick, and if the brick isn't empty, then we have to recalculate the voxel ray, because there's just like no way to actually, like, I don't know if that's faster. Because it's either that, or we like run the iteration algorithm several times without checking anything. And that's just also kind of weird, isn't it? Just run that until we are at the right place. Because that's like a billion Boolean checks. And I just don't buy that that would be faster. But like here, if traversal level equals 0, see, this has to be recalculated. I don't think it's that big of a deal, really. But it's also not great. And there are so many like else ifs here. I don't know. I feel like this is dog shit, but I also feel like it's how it should be almost. I don't really know how else to do this. But there are certain things like values here that I want to try group sharing later. Like, this is some bullshit. Let's be honest. And this here, this is actually alignment. So these, because I feel like using integers like this is bad. So here, for example, all of these should be stored as globals. Group shared globals. That represent alignments. And that way I can just do this. And then we can just have a function that returns an alignment. It could be this. I think this is probably what's creating the ghost bullshit. So next we should set up the surfaces. Because after that it's the convex and the concave corners, and those are gonna suck balls. But those are the most important. Like everything else is some weird edge case. Like for a terrain, for a generated terrain, the convex, the concave, and the surface, that's all that's missing here. The surface is 3. And it's just gonna look like this. First comes front. And front, that's just gonna be 031. Three, two, one. Break count equals 2. Return. That's front, then we want bottom. That's 0, 3. No. 3, 0, 7, I think. 0, 4, 7. Left. 4, 0, 5. 0, 1, 5. Next is right. These are like all incorrect, I think. Yeah, these should be 0, 0. This is front, bottom, left, right. top. That's 1, 2, 5. 2, 6, 5. Then back. 7, 4, 6. 4, 5, 6. That doesn't work. Ah, hold on. These all need to be reversed. There. I was saying that the alignment, if the alignment was towards the front, then we should draw the voxel that's on the front, or the surface that's on the front, but it's the opposite. If the alignment is down, we draw a surface up. It works. We are reaching some... We've got some other problems here, though. But like this is working. But it's hard to tell. It's all the same freaking color. And then we just need to set these up. Now here, Oh, this actually looks more correct. Which makes it worse because it's supposed to like render the cubes as the cubes that don't really exist as surface should be rendered as not at all. It should just be skipped. Ideally, I think it would probably be better if it broke. So what we're doing now here is we're just not doing anything. But I think that's probably for the worse. Like here, try count of 0. We can just say color equals float 4. What's pink? So now we should get a bunch of pink instead. Yeah. There. I think that's better. That also doesn't eat performance, because that's one of the issues, right? Like if you find an illegal voxel, then it's just gonna shoot the ray to infinity through the world, and that's gonna destroy performance, so it would be hard to really tell anything. We should do... What is depth? Let's try that. I should set a spawn point somewhere. Are you serious? What is happening? I don't know what just happened. This isn't working at all. I feel like that should work. Oh, why is it so busted? Huh? I think it's because of this. So we're dividing by an integer. That turns the float into a integer as well. Man, why is it so fucked up? It's like it renders once and then it just breaks. Huh? I test divided by step limit. Right? This is gonna be like 2 divided by 500. And then we subtract 1 minus 0.0004. And then we multiply our color by that. Like, this works. Like, why is this busted? Oh, hold on. This is why. It's because I've gotten rid of this by accident. I'm not actually rendering. That's why. I don't think we're gonna set up any more sides today. I'm just doing some bullshit right now. Just making sure that we might be able to actually read it. But I don't feel like this is a good solution. Because I want the early steps to be more noticeable, right? That's really what I would want out of that. But at least it gives that a little bit of shape. A little teeny tiny bit of shape. But like, even if I do this, it doesn't really... It doesn't feel very good, does it? Why is it so strange? Oh, it's because these are traveling, like, there are diagonals and stuff, that's why. It is what it is. So next time we continue just implementing shapes. We've got these remaining. And once these are implemented, then the next step is to re-implement the code I was using before. We actually need it. The difference is that this time we have to do it more based on... It's almost like every vertex. There should be like 8 sections. Kind of. And it should just handle each vertex. And that way, if that vertex is unused, then we don't need to really bother. Now, it will be difficult to handle that still. Actually, I don't know how I will handle that. Man, this is gonna suck, gigantic dog ass, man. Yeah, that's gonna be something, all right. Because look, this is the problem. Like here. It's almost like I'm gonna have to invent some kind of rules here. Because let's say we have this shape here. Here, I'm gonna have to, for these two vertices, I'm gonna have to compare them to this and then lower them in the Y. Potentially also check like the Z. If it needs to be aligned to something that's thinner here. And maybe the same is true even here. I'm not sure. But I don't think so. I think I'll keep these maxed out. Same like with an aligned cube. I think any cube that's aligned should have its aligned side maxed out. Always. Well, not always. That's not true actually either. Because if we just have 3 voxels aligned like this, then this here can't just max this out, because then that might end up being like this. If this one is thinner. Because otherwise this one, just because this one is centered between these, this one will have to be maxed out just entirely. And I don't think I want that. If you were to dig on this with a shovel, it should get smaller around itself towards the center. And then these should also be recalculated. I mean, they're recalculated every frame, so it doesn't matter. But yeah, so see, that's why this is so complicated and annoying. There are so many niche things that, and why it's so hard. Like at some point you realize that, oh shit, there's too much stuff we have to calculate, or this is like impossible to calculate, so we can't do that, or whatever. But I think it'll be okay. I think this should work, because the previous implementation did work. It was just, and I could probably have fixed that, but I think this might be better unless we run into some problems based on this. I think I'm gonna ask in some more Discord servers, but I just feel like this is probably really basic, and I feel bad asking stuff like that. All right. I think that'll be that for today. But yeah, next time, more of these. See, like, as long as you just do it, it kind of goes by. But I think figuring out how to handle this later, to modify the vertex positions, that's going to suck hard, I think. It might end up with being like a million ifs there as well, like if index equals this and that and that and that and that and that, and if alignment is this and that. But we'll see. Either way, until next time, thanks for hanging. Have a good night. Bye-bye.